All right, this is the review for 3.1, really to 3.3, first half of it for the quiz. So this is really going to 3.3a, so the first half. All right, so use a graph of f of x equals 4 to the x to describe the transformation that results in each function. So this is an exponential function with a base of 4 and your variables up in the exponent. What that means for us is that we just making sure the base is the same. It's not going to affect the graph. It's just going, it doesn't affect how the transformations work on the graph. Just don't use that base 4 for any of the transformations. So for the first one here, I notice this plus 2. That means it's going to go up 2. And then I'm looking at, and here's a negative in front of the 4. So that means it's outside. So that means it's going to be something that has to do with a vertical something, and it's a negative, which is a reflection. So it's going to reflect over, and if it's reflecting vertically, it's reflecting over the x-axis. The next one, I always like addition, subtractions first. That's just me personally. This is inside up in the exponent. So anything that's inside, consider it inside, it's in the exponent. So this is a plus 4 in the exponent, so this means it's going to go left 4, because anything inside is opposite of what you think it would be. And then what else I have here is a 3 outside. This 3 outside, it's vertical, because it's outside. It's a number larger than 1, so it's a stretch, TCH, and then it's stretching it by a factor of 3. Then down here we have another exponential function. This one is a base of e, which is your where your natural logs come from and all that, but this same type of transformations. So describe the transformation. This 0.5 is up in the exponent. So this is going to be multiplied as well. So it's a horizontal. And it's a 0.5 inside. So anything between 0 and 1 is opposite of what you would think. You would think that's going to be a compress, but it's not. It's a stretch. And then this one's the one people get a little, I want to say it's stretched by half, but it's stretched by a factor of 2. So it's stretched horizontally by a factor of 2. 4 and 5 have to do with your exponential growth and decay functions. And the first one has to do with money and how it's compounded. So you have 2 functions going on here. The first one is P, oops, didn't put that back up, P1 plus R over N to the NT. And this is your principal amount. And your rate is R, and N is the number of times it's compounded. So this is semi-annually. So this N for this one is 2. And then N again up in the exponent. And then T is your time. You have another one, and that's when things are continuous. So continuous is your principal amount, a base of E, your rate, time. So for the first one here, we have a rate of 4% and interest over 10 years. So 4,000, 1 plus R, R we know. R is always as a decimal, don't put it as a percent. It's a 0.04 over 2 to the 2 times 10. Put that in your calculator, and you're going to get 5,943.79. So in 10 years, you'd have 5,943.79. Or it could also, how much interest have you gained? You've gained $1,943.79 in interest over those 10 years. Now, if it's continuous, we need to use our PERT equation. So 4,000. E, your rate's still 0.4. Your time is still 10 years. You put that one in your calculator. You get 5,967.30. So you gain just a little bit more if it was continuous. Now down here for population, it's pretty much still the same thing. I don't really think of the equations as very different, but I think annually, usually things are just one annually. So you take the amount that you started with, multiply it by 1 plus your rate to the time. And for continuous, you take your amount and take it E to, and I just say K for this one instead of an R. And so E to the KT. It's still your rate. Now, pay attention to this one. It's declining. Whereas up here, it was earning. Earning is a positive. Declining, it's a negative rate. So continuing here, because it's declining, that's a negative rate. Our amount is 16,000 people. And we want it for 5 years and 10 years. So I want to go 5 years here. I'm going to go 10 years down here. 1 plus, it's actually not plus, it's minus, as soon as I said that, because it's a negative rate, so minus 0.04. And the time for this one was 5 years. Put in our calculator, this one we get 13,046. I'm rounding it to the nearest person because you can't have part of a person. 1 minus 0.04 to the 10 years. It's going to give me 10,637. Again, to the nearest person, please. We don't have half person. Then over here for continuous, I'm going to do 5 years at the top and then 10 years at the bottom. So 16,000. E, our rate is still negative 0.04. And then 5 years, 13,099. And then 16,000 E to negative 0.04 times 10. For 10 years, it's decreasing at that same rate. We've got 10,725 people. So that's how you do it. That's a lot of memorizing the equation, knowing what the equations are, what to plug in, using your calculator to solve it. So number 6 is bringing back in some stuff from chapter 2. I want to know any asymptotes and any intercepts. It's already factored for you, which can be good and bad. It helps you with parts of it, not other parts. So I'm going to go through and do the parts that use the factored. First thing I notice that nothing reduces out, so none of my factors cancel out, so I don't have any holes. That means that every factor from my denominator is going to give me a vertical asymptote. So my first one is x, so it's x equals 0. The second one, x minus 5 equals 0, so that's x equals 5. My third one, x plus 2 equals 0, so that's x equals negative 2. Because remember, you're solving it, which moves it to the other side, which makes it equal to the opposite. And then the next thing is that my numerators give me my x-intercepts. So this is going to be an x equals negative 6 and a negative 4. So I have 2 x-intercepts. My vertical asymptotes, any asymptote is an equation, so you can't just give me a number. It's an equation. And so the next thing I know, I'm going to go through and I'm actually going to multiply it all out. So my numerator, when I multiply it, I get x squared plus 10x plus 24. My denominator, I'm going to get an x cubed minus 3x squared minus 10x when I multiply all that. What I notice, I could have done this before without multiplying it out, but I went to show you, is that the degree in the numerator is 1 larger than the degree in the denominator. It doesn't really matter how much larger it is, but it is larger, which means that my horizontal asymptote is y equals 0. If the degree is the same, it would have been leading coefficient over leading coefficient. And if the numerator is 1 more than the denominator, the degree, then I would have a slant. But I do not have a slant. And then my y-intercept comes from my constant of my numerator divided by the constant of my denominator, which I don't have. So there is none. I do not have a y-intercept. This one's bringing back a little bit of old stuff again. It says find the average rate of change over the interval. This is an interval. This is not a point. So these are both x values for this function. So since those are my two x values, I need to plug them in. So f of negative 5, when I plug it in here, what I get is a 1,320. And then I find f of negative 3 because that's my second x value. I substitute it in, and I get 184. And so slope, which is the average rate of change, another way of saying slope, is the change in y. So these are my two y values because f of x, that's y. So 1320 minus 184 divided by change in x. So my two x values, negative 5 minus a negative 3, which gives me 1,136 divided by negative 2, which gives me negative 568. So that is my average rate of change. Number 8 says to analyze the graph of this function. Now, I didn't make you analyze the graph on the exponential, but I am on the logarithmic. So you're going to have one function that you're going to have to analyze the graph. So this one just happens to be the log base 2 of x. If I graph it, looks something like this. Apologize, it's not the best, but it'll work. Remember, we have an asymptote here for our logs, and they are inverse functions of our exponential functions. And so graphing this, my domain, that's all your x values from left to right. It starts at 0. It does not include 0 because it's an asymptote, and it goes up to positive infinity. My range, it's from negative infinity to positive infinity because nothing stops it from going down or going up. I have an x-intercept, so as long as nothing gets shifted, an x-intercept of 1, 0. Do not have a y-intercept. If it were an exponential function, not a log function, this is a log function, but an exponential function has a y-intercept of 0, 1, and then it does not have an x-intercept, so that switches. Asymptotes. It does have an asymptote at x equals 0, and that would be the y-axis. My end behaviors, be careful on this one. So the limit as x goes to positive infinity, because the right side's going to positive infinity, f of x is going to positive infinity. But my left side, it's not going to positive infinity because it is going to an asymptote. So it's going to 0 from the positive side. So remember right here, it goes this way, it's going to 0. It's not going to positive infinity. So f of x is going to negative infinity. So it's going down. And then the last one is asking about increasing and decreasing. Well, it increases from 0 to positive infinity. Again, pay attention to those asymptotes. And then it never decreases. So going down to number 9 now, because that was number 8. It's all that information about that function, what it's like. I have to tell you about the transformations. Again, I like to start with addition and subtraction because those are the left, down, up, right. So this one, the minus 2, it's not up in parentheses on the x, so that means it's outside. So anything outside moves it vertically. And this one is minus 2, so it's going to go down 2. And then right here, this 1/2, it's outside again. And so because it's outside, it's a vertical. So it's a vertical. It's between 0 and 1, so it's a compress. Remember, negatives and numbers are separated. So if it was like a negative 1/2, it's still a 1/2, but then it's also a negative. So it's a vertical compress by a factor of a half. Or it's multiplied, I guess you could say multiplied by 2, or sorry, multiplied by a half. And so let's write that. Because you're compressing it, it's multiplying it by a half. There's a couple different ways to say this. We've talked about that in class. All right, number 10, we need to express log of 75 in terms of only log 5 and log 3. So this is into section 3. And so we haven't finished section 3, but we started it, and we're going to put that one on the quiz. So we need to break up 75 into only 5s and 3s. So 75, over here, 75 is equal to 25 times 3, and 25 is 5 squared. So that comes into 5 squared times 3, but I have to break it apart. It has to be expanded because that's not a log 5 and a log 3. So multiplication will split into addition. And that's still a 5 squared. It's not just a 5. So remember, exponents come out front into multiplication. So then that's my answer. 11, I need to evaluate without a calculator, which means you may have some variables on your quiz with this instead of just numbers. So in order to do this, because this is a log by 6, I need to get this to be 6 to some power. Well, 36 is 6 squared. Now a radical is really a fractional exponent. So that's 6 to the 2/3. And once the bases are the same, it reduces to just 2/3. And that's my answer. So right here, this is actually even easier because it's asking you to do this. Just be careful a little bit on this one. Right here, log and base E are inverses, so they reduce to 9. With this 4 here, it's out front, and then log and base E, they reduce, and they cancel each other out, so you're left with a 3. So this is 9 plus 12, which gives us a 21. 13, I want you to expand it. Remember, you cannot break up addition and subtraction, but you can break up multiplication. So this one becomes the natural log of y plus 5 minus the log of 4. And I'm going to go ahead and write this y to the 1/2. Now, this is multiplication, but it's grouped under this subtraction. So when you expand and separate those, you need to be careful because they're both going to be subtractions. So this is log of 4 minus, sorry, I need to rewrite the log. So don't do that on your quiz. Make sure you rewrite the log. And y, but there was a 1/2 in the exponent, and the exponent goes up front. So the 1/2 goes in the front here. So that's all expanded. And then the next one says to condense. So I start with my natural log. I see the subtraction, so I know it's going to be a fraction. I've got a 6x minus 1 in the numerator. And this 4 is the exponent on the x. I've got to put it up there, so x to the 4th. And then it says plus. It's not in parentheses, so that means whatever comes after that addition sign goes up in the numerator. So this is x minus 1 in the numerator. And the last two say to evaluate with a calculator. So just put these in your calculator. Make sure you can do them. This one's 1.9156. And the next one, the last one, is negative 2.5850. Now on the review, I did not put a difference quotient, but you will probably have one of those. So make sure you can do that one as well.